In this video, I'm going to talk about the coordinate plane and how to graph on the coordinate plane. So when we graph in general, it's important to understand how many variables you're working with. And so if you're graphing in one variable, you're going to use a number line. You're not going to use a coordinate plane. So for example, if you were asked to graph x equals 3, we would use a number line in this situation if we're only considering x, and that's the only variable that we're working with. And so we would draw a number line, we would find 3, and we would plot a point at 3, and that's how we would graph x equals 3. And in a number line, it only is in the horizontal. It's only in, basically one dimension. So you can go left, you can go right, and that's it. I'll give you another example. If you had to graph x is less than 2, okay, now this is one where you can actually graph this in 2 dimensions, but in this case, let's assume that we're only working with one variable x, and so you could use a number line, and you could find 2 on the number line. And I'm going to use an open circle since it's less than and not less than or equal to. And then less than means I shade everything to the left, and that's how I would graph x is less than 2. So if you're graphing in a 2 variable situation, then that's different. You're going to use what's called the coordinate plane. And an example of a coordinate plane is down here below. So I've got a vertical axis called the y-axis. I've got a horizontal axis called the x-axis. So here we have 2 dimensions instead of 1 dimension like a number line. The very center, we call it point 0, 0, or the origin. Okay, and this is a graph where you could graph what's called an ordered pair or a coordinate pair. And that's instead of graphing one number, you're graphing 2 numbers since you have 2 dimensions. So for example, we're going to plot the pair 1, 2 on the graph below. And so to do that, we're going to talk about in general, when you have a coordinate pair, well, what does each number mean? So a coordinate pair consists of 2 numbers, and the first number is going to tell you to go either left or right. So that's the x variable. And the second number, the y variable, tells you to go up or down. And so if that first number is negative, that means go left. If it's positive, it means go right. If the second number is positive, it means go up. And if it's negative, it means go down. And so it's a set of directions that tell you how to move from the origin. So it's really important that you know that you're starting at the origin. So what we're going to do to graph 1, 2 is we're going to start at the origin. And since the first number is 1, that's our left and right number, so it's positive. So that tells us to go right 1. And since the second number is 2, that means up 2, since it's a positive 2. And so from the origin, I'm going to go right 1, up 2, and that's where I'm going to put my point. So this point right here is 1, 2. The ordered pair 1, 2. So now here's a good question. Is the point 2, 1 going to be in the same location? Well, let's see. Let's use our directions, and I'm going to write this out in words here. What is this asking us to do? So if the first number is 2, that means go right 2. And the second number is 1, means go up 1. So I'm going to start at the origin, and I'm going to go right 2. And I'm going to go up 1, and then I'm going to place a point there. And so this is the point 2, 1. So you can see they're not in the same location. So there's a reason why we say ordered pairs. And the reason is because the order matters. So even though we had the same exact numbers, they were in different places. And so they gave us different directions. So it's kind of like saying, if you left your house, go 5 miles north and 2 miles east, that's different than saying 2 miles north and 5 miles east. You'd end up in a different place. And so let's graph another couple points here so we can see how they would look on the coordinate grid. So let's try one with a negative. So let's say we had to graph -3 and then +4. So what does that mean? So the -3, that's your left-right number. So since it's negative, that tells us to go left 3, and a +4 means to go up 4. So I'm going to start at the origin just like I did before, and I'm going to go left 3, and I'm going to go up 4. And usually when I graph, I don't show these arrows. You only need to show where the point is, but I'm just using these arrows so that it's really clear which direction I'm moving. So this would be the point -3, +4. And the other thing we could do here is we could also write this coordinate pair, ordered pair, in a table of values. So I could also write it like this. I could make a table, label one x and one y, and I could list this point like this. So I could write -3 in the x column and the 4 in the y column. This is the same thing as the point -3, 4. So just a different way to write it. Okay, so let's try another one. So let's do one where both are negative. So let's graph the point -4, -1, or on the table we could write it like this, -4, -1. So since they're both negative, that first number being negative tells us to go left. So this is going to be a left 4. And since the second number is negative, that's going to be a down. So we're moving down 1. So I'm going to start at the origin and I'm going to go left 4. So 1, 2, 3, 4 left. And then I'm going to go down 1 and that's going to be my point. So it's going to be down here, which is -4, -1. And then I know I mentioned it, but just to be clear, so the origin is right here. So this is the origin. That is the point 0, 0. So 0, 0 just tells us to start there and don't go anywhere. And so that would land you right where the origin is. And I could even put that in my table, 0, 0. So for this last example, I want to graph an actual equation. And so think of the equation, we're going to look at the equation x plus y equals 4. And when we talked about equations in a previous video, we talked about how when you have an equation like this, x plus y equals 4, it's true for infinitely many pairs of x and y values. So for example, x could be 1, y could be 3. 1 plus 3 is equal to 4. X could be 0. 0 plus 4 is 4. I could say 2 plus 2 is 4. You could keep going on forever and ever. There's infinitely many of combinations where you could add two numbers and get 4. And so when we graph this, basically what we do is we create a picture that graphs all of these ordered pairs that work. And since there's infinitely many ordered pairs, we connect them all and they actually end up making a line. And so what we can do here is I'm going to make a table of values, just like I did in the last example, and I'm going to find some of these coordinate pairs or these combinations of x and y values that work, and I'm going to write them down in my table of values. And then I'm also going to list them as ordered pairs. And so my first example here, I said 1 plus 3 is 4. So if x is 1 and y is 3, then that satisfies this equation. And so I could write that in my table, x is 1, y is 3. Or the ordered pair for that would be 1, 3. And then what I could do is plot it. So I start at the origin and I go to the right one, up 3, and I plot a point. Okay, my second example, x could be 0, y could be 4. So that's the coordinate 0, 4. So I start at the origin, I don't go left or right at all, and I just go up 4. And then I plot a point. And then my next example, 2 plus 2. So x could be 2, y could be 2. And so that's the coordinate 2, 2. So I go to the right 2 and I go up 2. Let's try a negative value. So what happens if x is, I don't know, maybe -3? So what happens if x is -3? Well, -3 plus what equals 4? Now you have a couple of options there. You could think about it like almost just, you could think about it from a number line perspective. So x is -3. What do you have to do to that to get 4? Well, you'd have to add 1, 2, 3, 4, 5, 6, 7. Okay, so -3 plus 7 is going to give you a +4. So you could approach it from that way. So -3 and a +7. So that would be the coordinate pair. Okay, you could also solve it as an equation. So -3 plus y equals 4. Well, how do you solve that? You add 3 to both sides, and you get y equals 7. And so you can come at this from a variety of different methods, whichever you prefer. So at this point, I'm going to plot the point -3, 7. And that actually ends up being a little bit off the graph, but I'll put a point up there. Let's see what happens if maybe I make y negative. Maybe I make y, I don't know, -1. What would x have to be to add, what number would I have to make x so that I add -1 and I end up getting 4? Well, let's solve that. So x plus -1 equals 4. You could add 1 to both sides. X would have to be 5. So 5 plus -1 is 4. So 5 comma -1, that could be another coordinate. So I go to the right 5 and then up, or I'm sorry, down 1. Now notice I almost said up 1 there. I almost made a mistake. Watch what happens. This is my mistake point. So had I done that, you can see here that if I connect all of the other points, I get a line. And so if you ever, in this type of situation, if you have an equation that's what we call a linear equation, where you have an x and a y and neither are squared or cubed or have any exponents, they always should line up and make a line. And so if you have one point that's not in the line, then that tells you, you know what, maybe I should go back and see if that's a mistake. And so you can keep going forever and ever. And you can see that some of the values, like this one way up top here, is off the graph. And so, if you ever, are doing a problem like this and it is off the graph, then feel free to pick another value and just use the ones that are on the graph. You only need 2 points to connect to make a line. A couple more is always a good idea, but you have some flexibility in terms of the numbers that you're picking. So in general, this is how you could graph this line. And then I want to show you just one more thing real quick. There are some really nice free graphing softwares or graphing websites online. One of them is called Desmos, and I'll show you what that looks like. So if you go to desmos.com, this is what you'll see, and you don't even have to sign up for anything. You can just click on Graphing Calculator, and you go up here in the box, and you can just type x plus y equals 4. And the nice thing about this graphing website is it's not like the graphing calculator where you have to have all the graphs solved for y. You can type it in exactly how your equation looks in the problem, and then it graphs it for you. And from here, they even show you where it crosses the x-axis, where it crosses the y-axis. You can zoom in by pressing the plus and zoom out by pressing the minus in the top right hand corner. So graphing by hand and knowing how to do it is a really great skill, and it's good to know, but it's also good to know what type of resources you can use to help you graph or just check your work if you need to.